Hello everyone, I am Maximilien LEHUJEUR. I will try in this presentation to summarize some of the main results I have obtained during this postdoc that I have done at the Observatoire Midi-Pyrénées of Toulouse over the last 2 years under the supervision of Sébastien Chevreau in the LEHUJEUR project, which is a project supported by the CNRS, the BRGM and Total. So the topic of my talk will be ambient noise surface wave imaging of a sedimentary basin by extracting coherent wavefronts, and I will show the application of the method we have developed to the MOPASAC experiment. The MOPASAC network is a dense network that included about 450 stations with broadband, short period and geophones, and that operated for about 6 months in continuous, which generated a large amount of signals, about 10 terabytes of continuous data. The first signal that could be extracted from this dataset was a large number of local earthquakes that could be detected and located, and some of which having very small magnitudes, local magnitudes. Apart from these numerous earthquakes, most of the signal that has been recorded by the network consists of ambient seismic noise, and this is the signal I have been focusing on during this postdoc. For example, on the bottom of the slide you have a spectrogram which shows the temporal evolution of the ambient noise level, and you can see these red patterns that correspond to oceanic storms mostly. So we used the array to estimate the origin of the ambient noise sources, and we observed that almost the ambient noise comes from a very few specific directions that correspond to the western direction, so the Galicia direction, the Irish coast also, and a little bit also from the Mediterranean Sea. So all of these arrivals correspond to surface waves, but we could also detect a weak but persistent body wave with subvertical incidence that also correspond probably to the oceanic activity. So this suggests that the noise we record with this network corresponds mostly to a superposition of coherent wavefront that originates from these few specific directions. So to illustrate what I said before, this is an example of waveforms obtained by few stations of the array for 10 minutes of signal, where we cannot see any clear coherent signal. But if we use all the stations of the array, and if we align the traces as a function of the dominant source detected for this time window, we can clearly see some phase alignments that correspond to the surface wave crossing the array from west to east in this case. So what we did during this postdoc was to implement a method to extract this information, and it provides us a condensed virtual wavefront from a source located at infinite distance. So a convenient way to display the same result is to use this kind of movie where you can see the extracted relay wave crossing the array from west to east in this situation. So we obtain this kind of observation for every direction and every period, and the interest is that we can obtain not only the phase but also the amplitude of the signal, which are both informations that we can use for imaging. So based on this approach, we could obtain a surface wave velocity model of the area for different periods between 2 and 9 seconds approximately. And this is a comparison with another model that was obtained by Antonio Villasenor using local earthquakes at different depths. So what we observe is that both methods provide us highlight the same first order structures, especially in the shallow part of the model. For example, regarding this very low velocity anomaly in the Arzac basin, or regarding this elongated structure that probably correspond to a shallow sedimentary structure. Okay, so to make a fair comparison between these two models, we have attempted a depth inversion of our surface wave velocity maps, and this is a section across the inverted VS model, which again shows some similarities between the first order structures. We still have some important differences that need to be understood in more details, and which is the goal of an ongoing work. I will conclude this talk by saying that these two datasets offer us a good opportunity to better understand the resolution potential of both approaches, and this motivates us to develop some new joint inversion approaches in order to benefit from both datasets. And thank you for your attention.